Hi, we will see one complete example on Rootlocus. Take an example g of s equal to k by s into s square plus 4s plus 5 with a unity feedback. So we will have three open loop poles, one at origin and the other two is a pair of complex conjugate poles, that is -2 plus or minus j1. As it has three open loop poles, the number of branches equal to 3. To see the part of Rootlocus on real axis, take any point on the real axis and look to the right side. So we can see that the complete negative real axis, any point when we look to the right side, we have only 1, 0 at origin. So the complete real axis on the left hand side of j omega axis is part of Rootlocus, that is negative real axis 0 to minus infinity. Plot the open loop poles and zeros if any. So this is one at origin, the other two -2 plus or minus j1 complex conjugate pair, and the complete minus real axis is part of Rootlocus. Then get the angle of asymptotes. Angle of asymptotes is given by plus or minus 180 into 2k plus 1 divided by number of poles minus number of zeros, that is open loop poles and zeros. In this case it is equal to 3, so you get the angles as minus 60, minus 180 and minus 300. Now to get the centroid, that is meeting point of asymptotes, sigma real part of zeros minus sigma real part of poles divided by p minus z. So that comes out to be minus 1.33. Now we have to find out the breakaway point and break-in point if any. Break-in point happens when you have open loop poles and coming and breaking at the real axis. So s cube plus 4s squared plus 5s plus k equal to 0 is your characteristic equation. From that we can get k as minus of s cube plus 4s squared plus 5s. Differentiate it with respect to s and equate it equal to 0. And the value of s, we will get it as minus 1 and minus 1.67. As the complete negative real axis is part of Rootlocus, both are valid breakaway points. To see the graph, you can see minus 1.3 is your angle of centroid. So the angle of asymptotes minus 60, minus 180 and minus 300. Angle of asymptotes mean at infinity the Rootlocus meet the angle of asymptotes. And we have breakaway point as minus 1 and minus 1.67. So these two are the breakaway points, minus 1 and minus 1.67. Now the angle of departure theta is 180 minus 153.43 plus 90. How we got that? Consider this open loop complex pole. Get the angle contributed by the remaining two poles. If you have zeros, you have to consider that also. So the angle contributed by this pole is minus 153, and from the complex conjugate pole it will be minus 90. So 180 minus these two, sum of these two, which gives you minus 63.43. So if the angle of departure from one pole is minus 63.43, the angle of departure from its complex conjugate will be 63.43. So with that angle of departure, the root locus moves. Now, the point at which the root locus branch cuts the j omega axis, put s equal to j omega in the characteristic equation. So you get the equation as j omega cubed plus 4 j omega square plus 5 j omega plus k. Equate the real parts and imaginary parts equal to 0. You get that omega equal to 0 or plus or minus root 5. So take the point omega equal to plus or minus root 5. And when you get the real parts, you get k equal to 20. That means at root 5, the value of k is 20. So you can see the complete root locus here. 3 root locus branches. That is one starting from 0 goes to infinity like this. The other one starts from other one starts from this open loop pole, goes like this. And the third one starts from this open loop pole and goes like this. That is 3 open loop poles and no open loop 0. So 3 branches starting from all the 3 open loop poles and ending at infinity. So this is the MATLAB plot of that. In the MATLAB, you take any point and you can get the complete detailed values of k etc. at that point gain, and you can see that the value of k at the open loop poles equal to 0. Thank you.